So we started a new unit on solving systems of equations, and the first method that we learned to solve was by graphing. Now, our topic for today is just on graphing linear inequalities. We've graphed linear equations, but we haven't graphed linear inequalities. Now, why we're doing that at this point is our next topic is graphing a system of linear inequalities and solving that system. Okay, so let's take a look at the warm-ups. And I've asked you to graph these linear equations. So number one's in slope-intercept form. So my y-intercept is 0, 3, my slope is 2. So I start at 0, 3, up to right 1, down to left 1. All right, number 2 is not in any good form. So I got y by itself. I subtracted 6, and then I divided all terms by 3. I would write that as 1/3 x minus 2 equals y. My y-intercept is 0, negative 2, and my slope is 1/3. So up 1, right 3, or down 1, left 3. Now, I would like you to add 2 questions, either at the top of your notes or squeeze them in with the warm-up. I'm going to just go back to solving basic inequalities. Remember, inequalities have how many answers? Yes. Most inequalities have infinite answers, so that is why we always used a number line to show our answers. I mean, back when we were solving just simple equations, we typically had one answer, all right? And so when we did inequalities, we had to show a graph to show they were infinite. So let's add number 3. If I asked you to solve this inequality, 4x is less than 8. If we divide by 4, we get x is less than 2. So that means any number less than 2 is an answer. All right, so to show that, remember, 2 is not an answer, so I have an open circle, and then I show everything to the left of the number line. So negative 5 million would be an answer. Okay, let's go to the next one. Let's add this to the problems, the warm-up problems. Solve negative 3x is less than or equal to 9. All right, so if I divide by negative 3, remember, ding, 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 when you divide by a negative, you have to reverse the sign. So now this would be x is greater than or equal to negative 3. Sorry. Now, greater than or equal to, so negative 3 is an answer because it's equal to, so that's why we do the solid circle, and then we go to the right. Okay, so now, how do we solve a linear inequality? Okay, so let's take a look at the first example. I am graphing y is less than or equal to 2x minus 1. So you approach this like you would lines. So my y-intercept is 0, negative 1. I would go up to right 1, up to right 1. Now, first of all, this is less than or equal to. So if you have an equal to, you're going to make this line solid. It's kind of like the filled circle on the basic inequality here. Okay, so if you have a less than or equal to or greater than or equal to, the line is solid, like a solid circle here. Now, how do we show that all of our answers are not just on this line, but they are below this, but they are less than? So less than means that we shade below, less than low. All right, so greater than, which that's not the case, I would shade above. Okay, so this line, this is a less than or equal to, so I would make this a solid line. Less than, I would shade below. Now, we know that when we graph a linear equation, all the points on the line are answers to that equation. Well, when we have a linear inequality and it's less than or equal to, all the answers on the line, all the points of the line are answers, but all the points below are answers as well. So I always tell you to test a point. Now, by what I shaded, would 0, 0 be an answer? No, it would not. So if I put in 0, 0, I should get a false statement. So if I put in 0, 2 times 0 is 0, I get 0 minus 1 is negative 1. 0 is less than or equal to negative 1. That is false, and that is not shaded. Now, if you don't like doing that, sometimes I tell students to go ahead and pick a point that's actually in here. Looks like, I don't know, 3, 3 would be a point. Okay, so if I put in 3 for x and 3 for y, I will have 3 is less than or equal to 5. That is true. All right, let's go to example 2. Graph this linear inequality. Y is greater than -2. Okay, so first of all, I have a special case. It's a horizontal line, and it will be crossing the y-axis at -2. Now, it's everything greater than -2. So the points, remember how this line would have the point 1, -2, 2, -2, 3, -2. None of these points are answers because it's bigger than this. That's why this is dashed. Now, greater than means above. So I would shade everything above. And all of these points are answers. All right, let's go to example 3. I have y minus 2x is less than or equal to -2. So just like everything else with a line, we want to get y by itself. So the only thing that is different when we're graphing linear inequalities, we have to look if the line is dashed or solid, and we have to look which way to shade to show the infinite amount of points. Okay, so I'm going to get y by itself, and I'm going to graph this just like I would a line. So my y-intercept is 0, -2. My slope is 2. So I can go up 2, right 1, up 2, right 1, or down 2, left 1. Now it is less than, so I'm going to make a dashed line because the answers, the points on the line are not answers since it's less than. And then I'm going to shade below, low, less than. All right. So let's take a look at the last one as far as graphing. So I have x plus 2y is greater than 6. So I'm going to get y by itself just like I normally would. I'm going to subtract x and divide by 2. So my linear inequality is y is greater than -1/2 x plus 3. So again, I'm going to start at my y-intercept. It's a negative slope, so I'm going to go down 1, right 2, or up 1, left 2. So hopefully I wrote this down correctly. It is greater than, so it is a dash line. Greater than means above. So all of these points above this line are answers. Okay, the last one is going backwards and writing the linear inequality. So the first thing I would do, I already have the answer here, but how I approached this was, I first of all decided upon my y-intercept. So when I started writing this down, I said my y-intercept was 3. And then I counted on my slope, on my points. I went from point to point. So I found my slope. Okay, so I decided on my y-intercept first, and then I went from point to point. So I went up 2, right 1, or down 2, left 1. So my slope is 2. So I know I have 2x plus 3, but now I have to decide upon my inequality sign. So since this is a solid line, I know it's going to be equal to. Since I shaded above, greater than, it's greater than or equal to. So again, this lesson had nothing to do with solving systems, but it had to do with solving just a linear inequality because our next topic is solving a system of linear inequalities. So graph these lines as if you've always graphed lines. The only difference is you have to decide if it's dashed, which would not mean equal to. And if it is less than or equal to or greater than or equal to, you will make it a solid line. All right, if it is greater than, bigger than, you're going to shade above to show all of those points are answers. And if it is less than, you're going to shade below.